Okay, this is Algebra 2, Section 2.7, Absolute Value Functions and Graphs. Alright, absolute value function is, I call it ABS. Absolute value function is when f of x equals the absolute value of x. So it's a linear function. It forms a V shape because as it comes down towards the negative values of x, since it's the absolute value, it bounces back up. And it bounces back up on a vertical line called the axis of symmetry, which is right down the middle. It's symmetric on that axis, and the maximum or minimum point of it is called the vertex. So vertex is the max or minimum, depending on the way that the graph is shaped. So the max or minimum point of the function. So, for example, I have absolute value graph is always in the form of a V shape. The axis of symmetry would be right down the middle. That would be my axis of symmetry. This guy would be my minimum vertex. If I had another absolute value function that looked like this would also be my axis of symmetry. And in this case, my maximum would be my vertex. So that would be a max because it's facing in the downward direction. This would be a minimum because it's facing in upward direction. And axis of symmetry goes right down the middle. The book says it's x when x is greater than 0, and it's negative x when x is less than 0. So what that means is that we have our x values, -3, -2, -1, 0, 1, 2, 3. Right? If we look at the part, absolute value of x equals negative x when x is less than 0. Let's sort of take a look at that for a second. If I have this -3, right, and I plug it into my function, it's going to be -3, right, according to this. So this would be a +3. This would be a -2, which would be a +2. -1, which would be a +1. Then 0 is 0. And then when x is greater than 0, or actually greater than or equal to 0, then the value is to stay positive. So x, 1 is 1, 2 is 2, 3 is 3. So we always have positive values of y. So when we do have a graph, it starts off like a regular linear function graph, right, for positive values of x. So once it gets to that negative value of x, then it bounces right back up and gives me positive values of y, which is why it's in a form of a V shape. Graphing these guys is pretty straightforward. So see, it says what is the graph of the function of absolute value x2? How is the graph different from the parent function? So if we was to graph the parent function, absolute value of x, goes right down through the middle. Right, here's my axis of symmetry. This guy would be my vertex at 0, 0. If I was to do x plus 2, it goes up 2 times on the vertical, on the y-axis. So the same rules that we've done up to this point applies to the vertical too. So if you add outside the absolute value symbol, you're going to go up. If you were to subtract outside of the vertical symbol, you go down from the parent function. So the parent function is through 0. If I add, I go up along the y-axis here. That's my vertex. If I subtract, I go down along the y-axis from my parent graph. So here are my translations. We just did vertical translations. If we add, it goes up. If we subtract, it goes down. Horizontal translations. If we were to subtract inside the parentheses, inside the absolute value symbol, not the parentheses, the absolute value, minus 2, it's going to go 2 units to the right. If we were to add, it would go units, whatever number units to the left. So this is x minus 2, it goes 2 units to the right. This is x plus 2, it goes 2 units to the left. If we were to do a reflection, and we had the negative sign outside the absolute value symbol, it reflects it across the x-axis. If we was to put it inside, it would technically reflect it across the y, and it would just look the same. Oops. So if the negative sign is on the outside, it reflects across the x. If the negative sign is on the inside, it reflects across the y. Vertical stretching, if a is greater than 1, it stretches vertically. If it less than 1 and greater than 0, it compresses vertically, it shrinks. So let's say it's 3 absolute value of x. It stretches, and if it's between 0 and 1, it shrinks, it pushes out. Compression, the green is compression, the blue is stretching. So we've seen all of that before. This is from 2.6. And we just done that. Here we have a situation where they want to know what this graph would look like. So since it's x minus 2 and it's inside the absolute value symbol, we're going to move it 2 spots to the right. And since there's a plus 1 on the outside, it's going to go up 1. So when we do that, it was x minus 2. So it goes to the right 2. But then it was also plus 1. That's going to go up 1. So it went 2 spots to the right on the x-axis, and it went 1 spot up on the y-axis. Yeah. Twice I did that. Compression and stretching, we just did an example, but we can do it again. 2x and negative 2/3 x. Alright, so 2x or 2 absolute values of x. And then negative 2/3 x. So that's going to, since it's negative, it's going to flip across to x in addition to compressing the graph. So this is 2x here. I don't know why it's black. I can't change the color. And then this is negative 2/3 x. Okay. So here's the general function form of that of the absolute value graph, and it's going to be in the form of y equals a x minus h plus k, where it's either stretched or compressed by the factor of a, right? So if a is greater than 1, the absolute value of a, then it's going to be stretched. If the absolute value of a is greater, a is less than that, greater than 0, then it's going to be compressed. And if we have our vertex, the vertex would be at hk. Where h would be your x coordinate, and k would be your y coordinate. The axis of symmetry is at x equals h. So whatever h is, that's going to be the spot where it reflects. That's where the v is going to take place. Okay. So when we look at this, we look at number 4. It says y equals negative 2x minus 1 minus 3. And they want to know the vertex and axis of symmetry, and then how is y transformed? Well, the vertex is hk. Our h is equal to 1. Our k is equal to negative 3. So then our vertex is going to be 1, negative 3. The axis of symmetry is at 1. How is it transformed? Well, since there's a negative 2, it's going to be stretched and reflected across the y-axis. It's going to be moved 3 spots to the right, and it's going to move 3 spots down. So let's look at that on the graph. So here's our parent function. We already have, it's going to be negative 2. It's going to move 1 spot to the right. And it's going to be moved 3 spots down. So reflected across the x-axis, 1 spot to the right, 3 spots down. Okay, writing absolute value function. It says I have a vertex of negative 1, 4. So I know that when I start my graph, I'm going to start it at the vertex, right? The vertex would be if I have a negative 1, 4. So that will be the start of my graph. I look at what A is, and according to this, it says A is negative 3. So I know it's going to be a downward facing 1/3. I'm sorry. I know it's going to be a downward facing graph, so I know it's going to go down here. And it's going to go down here at this vertex at negative 1 and 4. And it's going to be compressed, so it's going to be a little bit wider. It says K is 4, so I know it's going to be moved up one spot. So if I was to graph this, I know, or put it into a function form, it'd be y equals negative 1/3 absolute value x minus 1 plus 4. So it's going to be moving one spot to the right, facing downward, and moving 4 spots up. Now it says the phrase branching to the right, and what that means is that we want to take the slope. This would be our axis of symmetry. Anything to the right side of the function is called branching to the right. And anything to the left is called branching to the left. We would like to get our A value from branching to the right because it's basically like a slope of a regular line. So to find the A value is basically finding the slope. Branching to the right. Okay. So we have this particular function down here. First thing I want to do is find that vertex. So let's find the vertex. I see that it's 2 spots to the left and 1 spot down, so it's going to be 2, negative 1. That's my vertex. So I know that my H, or my axis of symmetry, is negative 2. No, I'm sorry. Yeah, H is 2. K is negative 1. Next step I want to do is find that slope. So I would take the slope from the vertex. So it looks like it's a wider one. So, and it looks like from branching to the right, it's a positive slope. So A is going to be positive, and it's moving 1, 2, 3, 4 spots to the left and 1 spot up. So remember, it's rise over run. So it's moving 1 spot up in my rise and 4 spots to the left. So it's a fraction. That's my A. So now I have enough information to write my, and I got that slope strictly from just eyeballing the graph. You could also do it by using the slope formula. This would be 6, 0. We already know that this is 2, negative 1. You can get the slope formula from that. Rise over run. Now I have enough. Y equals 1/4 x minus 2 minus 1. So this guy is going to be moving. It's an upward facing guy. 2 spots to the right, 1 spot down. Alright, that's this section. I hope you have a great rest of your day.